Right, guys, I've written something there which says degrees versus radians, introduction to radian measure of angles. The first line really, I don't know whether it's a very comfortable way of saying the best good way of saying it, but whatever it means, to me, I'm trying to make you aware that there's another way or another unit you can use to measure angles apart from degrees. Don't understand me in an awkward way if you've got something, some kind of attachment to what I'm going to say now. Degrees are based on beliefs. And as far as I'm concerned, beliefs don't need to be rational at any time. Beliefs don't need to be rational at any time. I can't really tell the history of degrees and whatever in 2 minutes or whatever. But the degrees, they've got something to do with the Greeks believing that, I don't know, that the sun or the earth was going around the sun in 360 days. Then because the kind of movement is sort of circular, then you divide the circle into 360 parts, then you call one part a degree, then you divide into minutes and you go to seconds and all those things. Then voila, you've got measure of angles based on beliefs. The problem with that, angles, when you come to science, degrees, when you come to very, very serious engineering or scientific calculations, degrees fail. They fail, you can't use them. Then that motivated the need to sort of get a measure of angles which does not believe, which is not based on the ancient Greek belief of degrees and whatever, sun is moving around whatever thing. And then what comes there is to talk about now, we're going to come up with angles in radians. So then the quick question is, what is a radian? The unfortunate thing is I cannot draw a perfect circle because I don't have tools to, and this software is not very good with me. But I'm going to just illustrate what I'm trying to say to mean there. Now what am I doing? I'm trying to make you experience what is the measure I call radian, measuring an angle. Let's say we've got a perfect circle here. My gods are very happy today. That looks like a perfect circle. Plus your imagination is a perfect circle. All together. Now we want to measure angles in radians. First thing, guys, everybody must understand that this distance from there is known to be radius. All together. Okay. Now I'm actually going to move away from the divisions around what? Around a circle to get a degree. I'm almost like throwing it degrees out through the window. How do I do it? Let's do it this way. I'm trying to make you feel what a radian is. Take a string or a fish line. Put it straight here. Put it straight, tangent to the circle. Remember, a fish line is flexible, isn't it? This fish line is long enough. Then I start pulling it this way, in the direction of, in this direction. And actually, that is the positive direction of an angle. If you are turning, if you are lifting an arm this way to open an angle, we call that angle, we say that angle is positive. If we pull it down this way, we call that angle is negative. I've got my own kind of understanding why people chose this thing to be positive and the other one to be negative. I'll show you what is my understanding later. Now, if I pull this, let's say this was a coin, like a 5 rand coin. Let's say this was a 5 rand coin. Let me write here, because you guys write 5 rand. This is a 5 rand coin. Then I take this fish line and pull it around the 5 rand coin. This fish line at some stage is going to be seen like this. Tell me if I'm wrong. It's going to be seen like this. At some stage, it will be pulled over like that. Do you agree with me? Then I'm pulling it around the coin. So at some stage, it's going to be somewhere there. Okay, but what I'm interested in a radian. If I take this piece here and find out this length here of an arc, this length of an arc is actually equal to the radius. Now the length of an arc is the length of the radius. Then at the end of that arc there, I can comfortably say this angle is 1 radian. That is the angle which is 1 radian. An angle which is subtended by an arc equal to the radius. It's an angle radian. Then when you start doing that, from that time onwards, angles are not measured in degrees. Angles are measured using real numbers. Like you measure time, like you measure things like length using real numbers. You can have something like 10,015 radians. Are we together? Okay. So let's come again to this fish line. Let's say I've pulled that fish line around. Let me just increase this right here a bit. Yeah. Let's say I've put that fish line around until it's standing straight this way, downwards. So where is it? It's actually tangent there on the line, on the negative axis. Then the angle there is actually pi radians. Now pi is a real number. Irrational number is a real number. So that's where you get people talking of pi being equals to 180. Then people write something like this. Pi equals to 180. Now the angle which is represented by the semicircle, which we normally call 180, is measured here in radians as pi radians. This thing. Are we together, guys? So we've got a radian, we know what a radian is. Then we've got something now we call pi radians. We know pi radians gives us a straight line in a semicircle, isn't it? Yeah. So from today onwards, when we want to talk about an angle of 180 degrees, maybe let's start changing the language and say a straight line forms an angle of pi radians. What I'm hoping now is that everybody is clear in your head that what is a radian, how to get pi radians. So now let's look at this. This is going to help us a lot. Now, if I wanted to know how to convert an angle from radians, now I need to be able to convert angles from radians to degrees and vice versa. Right. Let's say now we're saying here pi, remember this is radians, equals to 180. These are degrees. Now, if I want 1 degree here, I hope everybody sees that if I want 1 degree from 180, I must divide by 180, isn't it? So I can divide both sides by 180. Said 180 divided by 180. These are degrees. I hope people see that I'm going to get me myself 1 degree, is it? Then, but on the other side of the equality, coming this side, I will have to divide pi by 180. 180 as I'm dividing it here is not a degrees, it's just a number, isn't it? So now here are the degrees. So which is if I've got 1 degree, I've got so much of radians altogether. So now, which means now if I've got 30 degrees, I will need this to know how many radians I've got, is it? What do you mean? Each degree, each degree, this, each degree, this, each degree, this, up to 30. What is that? That's multiplication, is it? Altogether. So I will have to multiply this by pi of 180 to get the radians. What is that conversion? It's from degrees to radians, isn't it? So this is a degree. This is a coefficient which you can use to multiply degrees to change angles to radians. That's one part. So let me clean this a bit. Guys, if you don't understand something, please ask me. Don't wait for me to shout. So I've got 30 degrees. What I'm going to do, I want to convert this to radians. I'll get 30 multiplied by pi over 180. What I'm going to get here is radians. Then you will see that I'll get here 30 times pi. Sorry, 30 times pi over 180. I simplify. 30 is a common factor in 30 and in 180. What am I going to get here? I'm going to get pi over 6. So now you see angles which are measured by this kind of thing. Say the angle is pi over 6. But when you see that, you must know that these are radians. Am I making sense, guys? Okay. So what am I going to do? I'm going to leave this. You can ignore this part of the center here, but it's very important to focus on that and make sure that you know how to convert degrees to radians. All together. Okay. Let me get some space again and say that, clean that. Clean that. Let's do the reverse process now. I've got pi. I've got pi radians equals to 180 degrees. Now I want to know 1 radian. If I wanted 1 radian. I hope you can see that if I wanted 1 radian from pi radians, I would divide by pi. Then I'll give this thing equals to 180 over pi. Now when I get that factor, that kind of a factor, it's not really, this is a, I can say this is a radian. Altogether, this is a radian. So if I've got so much, I said this is conversion from degrees to radians, isn't it? So this one will help you convert from radians to degrees. then that is important also. So again, it's a question of multiplication, because every radian will be what? This degrees. Radian, this degrees. Radian, this degrees. So again, it's a factor which will multiply any angle in radian to take it to what? To degrees. Is that clear? Okay. So now, that fish line which I talked about, I can actually wrap it right round. Wrap it right round until I come back here to 0. But when I get there to 0, the angle is no longer 0. The angle is what? 360 degrees. And there is 2 semicircles. But one semicircle was pi, then the 2 semicircles would be what? Would be 2 pi. All together. Then you can tell me what is 90 degrees. It's half of 108, isn't it? So which is what? This will be equal to pi over 2. What will be 45 degrees? It's half of this one. Then this is pi over 4. So guys, today what did we learn? We can define what? A trigonometric function for any angle, which is not necessarily a right angled triangle. And we've got a new measure of angles independent of beliefs. For me, it's good for angles to be independent of beliefs, because beliefs are not supposed to be rational. So I think for that I'm going to stop there, hoping that everything is clear and you are going to engage and understand more. If there are questions, you come back to me, we discuss. Thank you.